special protection for Canada's Special Forces. We have an exclusive, explosive look at testing new protection for high-risk soldiers. I'm Ben Mulrooney in for Mercedes Stevenson. The West Block starts now. Canada's elite soldiers are at highest risk from close quarters blasts to close contact threats. While much news focus lately has been on larger military procurement issues, a program focusing on helping prevent brain injuries in special operators has quietly been making headway for the past several years. We speak with the head of that scientific program, and he walks us through exclusive testing. Canadian Special Forces are made up of small groups working out of the public eye and are highly regarded in security circles around the world. While they protect the security of our country and our political leaders in dangerous locations, a small team of researchers is trying to protect them. Defence Research and Development Canada has teamed up with Canadian Special Operations Forces Command, CANSOFCOM, to develop a cutting-edge way to protect those on the tough front lines from potential brain injuries, and other countries are taking note. We're joined now by the project lead, Simon Ouellet, who will later show us some exclusive lab tests. Hi, Simon. Thank you so much for joining us today.
Thanks for having me.
All right, let's talk about what's unique about this helmet. What's the difference between this and a traditional military helmet?
So there are a lot of things that are going to be unique about this next generation helmet. First of all, I would say it's going to be the lightest helmet that the Canadian Special Operating Forces have ever had. So that's a big plus. But what's even more importantly is that we're asking for a lot more out of the helmet now than we used to. So a regular helmet, or historically, we used to ask for the helmet to have the ability to stop high velocity fragments from penetrating through, and also the ability to mitigate the risk of severe traumatic brain injury from direct impact. Now we're expanding on that. So we're now considering risk for mild traumatic brain injury, trying to take that into account. And we're also asking it to mitigate the effect of low-level blast waves. So those are aggressors that might not cause injury by themselves, but over time might accumulate to negative effects. So we're now adding that performance requirement into the helmet. So in a nutshell, it's lighter and it's going to do more than the previous generation.
What are those other pieces you have with you?
So what's in front of me here is I have the latest version of the helmet prototypes. These aren't the final versions, but they're getting really close to the final product. And what I have here on my left is what we call an instrumented head form. So it's a head form that DREC has been developing for the last decade. And it's essentially a measurement tool that allows us to measure how good the helmet is at mitigating blast. So later today, we'll perform testing where we'll have the head form mounted on a full mannequin that's in an explosive breaching environment, and we're going to put the helmet on the head and measure how effective that is. And the measurement that we're taking, the most critical measurement that we're taking, are pressures inside this brain circuit. So this brain simulant is instrumented with pressure sensors that are cast within the material. And that's our main measurement to see how effective the helmet is.
Simon, who is this new helmet designed for?
So the current prototype is a CANSOFCOM led project. So it is designed with operators in mind. And when I say designed with operators in mind, I mean that it takes into account their operational reality. So when we set the bar in terms of performance, so what we want out of the helmet, we consider how operators operate and train. And this is where we evaluate the risk environment and then specify the performance that the helmet should have to protect their health.
Special operators have very unique jobs. Why do you believe that they need this?
Well, the idea here is that this is a helmet for the Canadian Special Operating Forces. So as I said, it is designed with their operational reality in mind. Now, it doesn't mean that all of these innovations aren't transferable to the Green Army or to the Canadian Army. They most likely will be, but first and foremost, it is designed with the operator's reality in mind.
How do you hope this helps those special ops?
How to help? Well, first and foremost, as I said earlier, it's a lighter helmet, so it's less of a physical burden to wear that helmet. And as you can see, I mean, the helmet is also a platform where we put a lot of technologies on top of it. So having a lighter shell, lighter helmet to begin with is already a big plus. But most importantly, because we're extending on what we're asking from the helmet in terms of protection, I think ultimately the Canadian Special Operating Forces are just getting better protected and against a wider range of potential threat.
Simon, on a personal level, why is doing this research important to you?
Well, personally, I mean, just like any, I think, the RDC defense scientists, we're very passionate about enabling the Canadian Armed Forces to accomplish their mandate. For us, it translates into protecting the health of our people and maintaining their readiness. And it's as simple as that. It is a nice technical challenge. It is from an engineering standpoint, it is very interesting and very challenging. But I mean, what really drives us is just protecting our people.
This can't have been easy. Talk to me about the challenges in designing this new helmet.
So because we're asking for so much out of this helmet, there are actually competing requirements in there. So as I said earlier, we're asking this shell to stop a high velocity fragment from penetrating through. And we want the shell to do that at a lighter weight. So lighter weight means, okay, light materials, maybe less structural stiffness, for example. But we're also asking of this helmet to mitigate direct impact to the head. So they are in all of this protective scheme, there are competing requirements, and that makes it very challenging. The other aspect that's very challenging is that we're now asking this helmet to mitigate blast waves or low-level blast waves. Blast waves travel in an environment in a very complex fashion. And it's a very, very difficult problem to deal with because it bounces off walls, especially when you're in enclosure. It reflects off surfaces, and it eventually attacks the head from different directions. So it's a tough problem to deal with, and it's competing with other requirements. And we're making great progress, and I think we'll get there by the end of this development project.
You allowed the West Block to film some of the testing you do, and we'll see that coming up. But what testing are we going to be seeing?
So we've been running the tests that we're going to see today. We've been running them throughout the development program. And that's our way here, and that's our role at DRDC, to track the progress of this development and make sure that we're moving towards the performance requirements that we've stated to our partner that designs the helmet. So they're very important to us because we're just making sure that we're moving in the right direction and that the goal that we've set for this project are going to be achieved by the end.
What's the next step? Looking ahead, what happens next with these helmets?
So we still have a year of development to go, which means that we're going to continue working with the company that's designing the helmet to improve its performance. So we're going to keep doing the tests that you are going to see today throughout the development until we're happy with the performance. And if we meet the performance we want earlier on in the project, we're just going to keep trying to push the bar and make it better. And next, well, the technology is going to be ready for procurement by the Canadian Special Operating Forces or any other group in the Canadian Forces. The other thing that's interesting is that all of the progress we've made in terms of our assessment approach, so the use of the head form, the blast testing that you're going to see, some of the impact testing that you're going to see, these are fairly novel in terms of assessment method, and we've been developing them for the purpose of this project. So the next phase for that is for us to share that knowledge and that experience with the Five Eyes community, hoping that these methods become standard across NATO nations and Five Eyes and all of our allies. Yeah.
Simon, merci beaucoup. Thank you so much for joining us.
Thank you. Anytime.
And coming up,
3, 2, 1.
Our exclusive Testing with Simon.